Hello everyone. Today we'll discuss about OpenvSwitch hardware offload performance with OpenStack Real-Time Compute node. OpenStack support like OpenStack Quinn release onwards. OpenvSwitch hardware offload and real-time has supported. So as an experiment, we explored the OpenvSwitch territory to hardware offload support with real-time kernel to evaluate the performance of OpenvSwitch for the deterministic traffic rate. So as a quick introduction, I am Pradipta Sahu. I'm working as a senior software engineer at Red Hat, mainly focusing on Red Hat hybrid cloud product ecosystem. Yeah, OpenStack have various features for the suitable for NAPI environment like SRIV, OVS TPTK, real-time kernel, and OVS hardware offload. So coming to the complex use case and advanced level use case like vRAN and 5G requirement, the telco application, although the telco application is expecting the network throughput performance, in the other side also it is required for the deterministic performance as well from the application side. So to achieve this requirement, OpenStack Cloud cloud service also leverages the functionality like real-time kernel, precision time protocol, and hardware acceleration. So to test this requirement, we have tried hardware offload performance with real-time compute node for this goal, like to achieve the deterministic latency in the guest vCPU in the real-time instance. And once we'll achieve the real-time instance, then we'll try the network throughput in various packet loss scenario as per the RFC standard. And during the entire test journey, we can verify the OpenvSwitch hardware offload stability, which has integrated with the 100 gig network as well. So like the real-time compute and the OpenvSwitch hardware offload have various functionality. Like I don't want to go through in details, but OpenvSwitch hardware offload is basically like it's mainly supported in specific network card which have the SmartNIC technology, where you can dump the programming flow from the software layer to the hardware layer. And the real-time kernel is mainly designed for the deterministic performance when we come to the any mission critical based application. And this is the network topology of OpenStack environment, where the thin layer is mainly belongs to the control plane layer to interact with your internal APIs, storage management, and other management access. And the thick layer of a network layer is mainly for the first data path, which rely on the 100 GB network. And from the traffic generator side, we can share multiple PCI info to achieve the 100 gig throughput for DUT side. Yeah, this is an closer view of network topology of net traffic generator and the real-time compute of DUT, where the traffic generator is configured with open source traffic generator software tool T-Rex, which is bind with multiple PCI info. Here, in this case, we are using 4 dual port PCI, which is each having 25 gig throughput. And each line rate is processing like near 200 gig throughput to meet the line rate of DUT. And in the DUT side, the server has configured with the real-time kernel, base OS, and guest OS, which having the software layer is having the virtual switch is configured with OpenvSwitch 2.13, and the guest side, the forwarder is running on DPDK based application as the test PMG tool with the test PMG tool. And yeah, this is the specification of our server. Like the duty host is belongs to Dell PowerEdge R740 XT model, which have the Intel Cascade Lake processor having two NUMA, where each NUMA having 18 physical CPU, and the reference here and all the reference details like the RAM is 192, OpenStack is 16.1 belongs, which is the upstream release is train, and the base operating system we are using real-time 8.2 kernel. And yeah, these are the reference details of virtual switch, DPDK, and traffic generator. Coming to the deployment part, like since this is a Triplo-based OpenStack deployment, so the Triplo deployer mainly deploying the overcloud environment with the default cloud image. So the default cloud image is not upgraded with the real-time kernel. So we need to customize the real-time kernel with a default image with the real-time kernel and the CPU tuned profile packages. And in the other side also in Triplo hit template, we need to pass the specific tuning parameter after the provision, which is required for the real-time configuration, such as like kernel port argument for the with huge space and CPU isolation, tuned for real-time profile, and desired image details, and the queue size of Nova, which mainly for the hypervisor, and the levered CPU mode should be host pass-through, and extra flag for the TSC deadline for the time synchronization. And there is an optional option available for if you are if your vCPU real-time scheduler priority to increase, that you can also pass this option real-time scheduler priority during the deployment. In our case, we proceed with the default one, which is the priority value is 1. In also in obvious hardware offload integration during the deployment, ensure that the environment file enable with the obvious hardware offload flag with desired OpenvSwitch offload breeze and the NIC. And in the NIC template of DUT, make sure that the link mode should be enabled with the switch step, which usually interact with the software layer to the hardware layer. As an NFPA recommendation, the compute node BIOS setting should be optimized. In our case, the Dell system profile, like the CPU power management, memory frequency profile, should be enabled with the maximum performance, where it will be it disable the turbo boost, C state, and other performance parameter as per the requirement of performance, system level performance. And if you have, and it is also recommended to disable the logical processor in the host. So in our case, we disable the logical processor to quantify the performance and without ST physical core. As the baseline test, like after the deployment, we have done the hardware detection tool. We use the hardware detection tool for latency measurement in real-time compute node. So in 1 hour test, we achieve 11 microsecond, which is give us the confident for the further testing in the in real-time guest. So the 11 microsecond is because we disable the turbo boost, which is for initial testing, the result was not good. So, but after optimize the BIOS setting, we achieved the better performance. Yeah, inside the guest, we tried the latency measurement using the open source OSLAT tool. It's mainly useful for your latency measurement of the isolated core which inside the guest. And we have done the testing with two-phase, like in the kernel boot parameter using mitigation on and off. So in mitigation off, we achieve like a deterministic latency, which is maximum is 9, and all the if and referring to the statistics, the all the uh, vCPU is maximum reached to the 9 microsecond latency. But when we tried with mitigation on, the statistic is not really deterministic compared to the previous result, and it achieved also maximum 15 microsecond. In the both results, we achieved as per our expectation, like it should be uh, below 20 microsecond. So and we tried the test with 12-hour test cycle. Yeah, and for further validation with network side, we continue with the kernel configuration without mitigation. So we keep the mitigation off in both compute and guest kernel. Okay, coming to the guest side, we upgraded the guest kernel to real time and the real time guest UND profile. And in the neutron side, neutron port side, we disable the security group, and we also binding the profile of the Swiss dev so that your virtual representative port should be enabled with the Swiss dev API to communicate with your hardware chipset. And uh, this is the like Nova flavor spec, which is the recommended for your and like telco application, the mission critical application which you are running for the in the real time compute node. So make sure that flavor spec is enabled with the real time dedicated CPU policy with real time flag and huge space configuration, emulator thread policy, and PMU disable with the PMU. And after the provision and inside the guest, verify that the respective memballoon option disable in LSPCI details, and you also need to configure the CPU isolation and the huge space configuration inside the guest. And after the configuration, you can install the DPDK application. And in our case, we use 19.11 libraries to execute as a forwarding application. And we execute and we configured the TSPMD forwarding in a single queue with single like where the PMD the poll mode is pinned to one vCPU, which is running on the real-time scheduler. And in the same way, like in the traffic gen also, we optimize the configuration. Like we are using pbench, which is an open source tool mainly designed for the collective system information for the benchmarking and in a granular form. So pbench have various benchmarking tool supporters, and the traffic chain is one of them. And traffic chain is also supported, the backend supported is T-Rex so far. And for the further optimization in the traffic generator host, we also need to enable the CPU affinity, CPU partitioning, and huge space configuration. And we dedicated 8 PCI for server to run the test. And we ran the test for various packet loss scenario like 0.002, 0.005, 0.001, and 0 packet loss for various frame size like 64 to 1500. Yeah, and once we completed the deployment, did the validation of latency measurement, and then we continued the test for the network throughput, where we have divided the test in two scenarios. The first test scenario is referring to the packet loss 0.002005 and 001, where we have done the testing with like three samples to consider the average performance and standard deviation in each sample rate. And each sample has executed in with the frame size 64 to 1500 for multi-streaming flows. In our case, we use 1024. The binary search we target like for 122 maximum validated the maximum line rate, and the final validation runtime is 10 minutes. So once it will validate the maximum line rate, then it will jump to for the further validation to run the validation runtime. So in the same way, we also executed the a 0% packet loss scenario, but in this case, we use the one sample test, and but we increase the binary search time so that it will take some more time for 30 minutes time for the binary search to determine the maximum line rate in zero packet percent scenario, and then it will run 2 hour test for with the same line rate. So in this way, we executed the deterministic performance in various packet loss scenario. And yeah, in the this is the results details. In the 0.002 packet loss scenario for fixed 64 frame size, we achieved like uh, um, 55.40 million packet per second with 27 Gbps throughput, and with minimal deviation. So, and if you check the statistics from the receiving transmit side and receiving side of the traffic generator is equal, so there is no major performance drop we achieved here. We know, yeah. And in zero packet loss scenario also we achieve 45, and this is this all the test is majorly executed in binary search. So there is no such performance degradation we have observed in the entire test. And in also in obvious offload performance in compute node, we observe like in the test journey, one of the offload bridge also, there is no such like performance drop or any kind of issue has reported. And all the packet rate in obvious offload bridge is looks steady. And in average, we achieve like 27 million packet per second in offload bridge in for the transmit and receiving side. Yeah, there are few challenges also we like experienced during the test. The first challenge is like specific to a bug. We observe like during the CPU latency measurement, uh, when we enable the IRQ balance, there is unusual CPU latency reported in virtual vCPU inside the guest, and this issue was reported when you increase the timeline more than 10 hours. And I have done 3 sample tests, and in 3 sample tests, in 2 samples, I report this issue has been appeared. So I'm working with the real-time team, and we are expecting this issue will be fixed in future. And the remaining 2 issues mainly specific to the environment side. So the second issue is like when we perform the sanity test uh, uh, after the deployment, the entire CPU compute node is went to hung state, and we observe like the software queue thread increased to near to 100%. CPU utilization is increased to 100. And in the same way, same time, the traffic generator also failed and reported a duplicate latency packet. So while narrow down the issue and further investigation in each layer, we figure it out. There is a faulty port is reported. Faulty port is like configured in the traffic chain, and once we move that port to the other ports, then the issue has been not reported. So make sure that when you have NAP performance test, all the underlying configuration should be in properly tuning and verified. Yeah, I think, I have completed my presentation. So these are the reference details I would like to share with everyone for configuration. The OpenStack document can help to configure the real-time compute and OVS hardware offload configuration. And yeah, the software details of uh, the to further troubleshooting inside the real-time compute node and OpenStack platform. And if there is any additional requirement for firmware upgrade, you can follow the Melnox software driver for further tuning. And the performance measurement tools, these are the reference link for Osler, Traffic Chain, pbench, and T-Rex, which we use in our deployment. Yeah, I think I'm done for my presentation. I'm ready to answer if you have any question. Thank you so much.